Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Everyone, it's my pleasure to introduce Liang Zhou and to welcome her here to MSR. Liang is almost finishing with her PhD next month, hopefully, or in the next coming months. And very interesting topic on various aspects of summarization. Single document summarization, multi-document summarization, summarization of blogs, of email threads, really a very wide spectrum, all on the topic of summarization. And especially Liang today is going to talk to us about evaluation and introducing paraphrase into MT evaluation and the evaluation of summarization. And that's I think, a very interesting topic. Several outside sites are already interested in asking Liang to put together a package for this evaluation. So I think there will be a lot of subsequent interest in this topic, and we'll be one of the first to hear about it. Thank you.
Okay, hi. So the title for the talk is called ParaEval, using paraphrases to improve machine translation and summarization evaluations. So just a short introduction for myself, if Lucy. I have been doing my PhD for the past 4 years, majorly just on summarization. So first I did automatic training data acquisition, and then headline generation and biography creation, and some query. So now I'm mostly focused on question-focused multi-document summarization, and some online discussion summarization as well. On the evaluation side, I was involved with the basic element framework, where we break in summary content into smaller units and do comparison. And so for this talk, I'm going to talk about a better comparison for text called ParaEval using paraphrases. And some other things I have done before was sentence segmentation and simplification for MT, and some speech processing for meeting summarization. So for this talk, I'm going to talk about why I'm doing evaluation currently. And this is moving from solving problems to looking at results. And then I'm going to talk about MT versus summarization evaluations, and what's the difference between them, and which one is more difficult. Then I'm going to talk about the focus of this talk, ParaEval for MT evaluation, and then for summarization evaluation, then I conclude. So solving NLP problems is, as we all know, taking a bunch of text and apply some model as complicated as possible. Then we find a solution like, wow, I'm the king of the world. Then it comes down to a really, really boring process where this guy just going like this. It's called evaluating results. And it also can be very nerve-wracking because you don't know what's going to happen. So here's the results. And you filter it through some weird-looking person or tool that's going to chop it up any way they want. Then, wow, you are a genius, and we can prove it. But more seriously, MT and summarization evaluations are very important because MT is an $8 billion industry, according to Slate.com, and the summarization, I'm sure, is a lot of money too. So it's important to distinguish which systems are good and which systems are bad, just from a purely monetary view. So evaluations are always better done by human because we always trust humans, and humans can do inference and understanding much better. But it's too costly and too slow. That's why automatic systems were developed. So this have enabled a rapid development in both fields, and this encouraged fast turnaround for design and evaluation cycles, and good for hill climbing for single systems, even though some evaluation tools may have problems distinguishing among systems, but still good for hill climbing. So the difference between MT and summarization is that all the current state-of-the-art MT systems translate one sentence at a time, and this enables evaluation to do the same, where this peer and reference sentences are very well aligned. But this does not exist for summarization results, because for summarization, we're shrinking a whole lot of information into 100 or 200 words. So this leaves a lot of possibility for the summarizer to choose what content they want to include. And this is also a reason why a good summary is hard to define, because even for humans, they have different interests, and they may just pick up whatever they are interested in and put into the summary. So for the evaluation, there's no nice sentence alignments. Basically, entire summaries are the limit to compare. So if you think empty evaluation is hard, the evaluation of summarization is even harder. So the current evaluation methods, automatic methods, are counting n-gram co-occurrences. So there's blue for empty evaluation and rouge from Chin-Lin for summarization evaluation. But both methods are based on lexical identity, where words has to be the same before they can be matched. So there are limits to those methods. Obviously, the lack of support for measuring semantic closeness. For blue, they try to compensate or lessen the problem by using multiple references, because multiple references provide alternative way of saying the same thing. So that increases the chance of matching one of the reference content with the system-produced translation. But still, we need to recognize paraphrases between peer and reference, or individually among them. For rouge, the problem is similar too, but it's more problematic due to the length of the summaries, because when links are longer, you're looking at a lot of different contents, and it's hard to make the match. So this has led to more manual annotation, like the pyramid evaluation currently, to be carried out. So to measure semantic closeness is a very hard problem. So we use paraphrases as an approximation. So paraphrases are alternative verbalizations that convey the same information. It's required by a lot of NLP applications, like question answering, summarization, generation, and a lot of more things. So incorporating paraphrases in recognition and matching into the evaluation process, we're allowing more contents from text being compared. Also, we hope that it will correlate with human assessment better than just using lexical identity. So to collect a large collection of paraphrases, we want them to be domain independent and also unsupervised. That's cheap and can be delivered in a really fast, timely fashion, but also has to be large enough to be general, to be applied to different applications. So previous acquisition efforts includes manual, where like people sit down and annotate which phrases are paraphrases of each other, but those things are domain specific. Also, there's different evaluation efforts that use WordNet to do evaluation, but we're more interested in more than just single word synsets. And also there's work from derivation from corpora, using multiple translations of the same classic novel, or deriving word lattices from multiple translations. They're very nice work, but the paraphrases collected are not large enough to be utilized on a larger scale. So our approach also was shown in Bernard and Collison-Birch, 2005, the ACL paper. We want to use a parallel corpus from MT and extract phrases in both languages. And if both of the phrases in like English translate into the same phrase in Chinese, we want to, if this happens often enough, we want to say those two phrases are paraphrases of each other. So here I showed an example where we have an English sentence and a Chinese translation, and we use Giza++ to do the alignments. And for the phrase extraction part, we use Oak and Ney, 2004. So bombing and blowing up are both translated into the Chinese word. Then we assume they are paraphrases of each other. So using this method, a list of paraphrases for bombing has been constructed. Here's a list. So as you can see, it can be like the phrases can be from different syntactic categories. We're not limiting them into the same category. So that's different from Bernard and Collis and Birch. Their purpose of using this method was to extract direct substitute phrases that are direct substitutes of each other for empty purposes. So for example, if I don't know the word bombing in English and I want to translate it into Chinese, but I know that I have seen bombing being a paraphrase to bombing attack in German, English-German parallel corpus, and I know the translation for bombing in Chinese, then I'll just use the translation for bombing attack instead of bombing. So they use the really nice n-gram language model to derive this direct substitute. So here I'm going to talk about the incorporating paraphrase into the ParaEval framework to do empty evaluation. So for example, those two sentences are supposed to be the translation of the same foreign sentence. So for blue, you only match the words in gray. Using ParaEval, we want to match everything that's in color plus the stuff in gray too. And also this word to and to were mismatched because today and to be today and to be, the other two is not supposed to be matched. Today and up until now supposed to be paraphrases of each other. So when we do paraphrase matching, we'll correct this mistake. So here's a recap on the blue detail of blue. So they calculate a modified n-gram precision using a technique called clipping. For example, this is to prevent a system that overgenerates good words. So for example, the candidate sentence has 7 appearances of the word the, and for the first reference, it only had 2. For the second reference, only once. So the score that the word the will get is only 2 out of 7. So a maximum score that this particular word will get is the maximum occurrence of this word in any of the reference translations. So we adopt this clipping philosophy in general. So instead, in addition to unigram clipping, we also do paraphrase clipping. But the underlying counting unit is still unigram. Our goal is to have this paraphrase support and also to support the calculation of recall, which blue also is missing. So for example, if the candidate translation has blown up, bombing, what's happening? This is only for demonstration purposes. And the first reference has bombing and explosion, and second one only has explosion. So recognizing that blowing up and bombing are paraphrases of each other, and also with the other two, we only give those 3 words 3 points because it made 2 paraphrase match, and this is precision calculation. So you get 3 points, and then the rest of the points were calculated based on lexical matching. So even though we're using only unigrams as counting units, this actually helps us to isolate the effects of calculating how the paraphrases really affect the whole matching process. And also, we are now complicated by a weighted n-gram scheme where different weighted coefficients were assigned to different lengths of matches. To evaluate the performance of ParaEval, we calculate the correlation with human rankings from the past MT evaluation exercises. So the goal is we need to distinguish good systems from the bad ones and systems from humans. So we used in this 2003 Chinese MT evaluation that involved 8 MT systems and 4 sets of reference translations. And in this human assessments were on fluency and adequacy. They also had rankings. So here I show the performance of ParaEval compared to blue. In both of the, so here is the correlation and the 95% higher and lower confidence interval. And ParaEval both performs both better in both accuracy and fluency. So the confidence interval were calculated by resampling all the translations 1,000 times and come up with a ranking each time for all the systems and compare the correlation. than taking the lower and higher 95% interval. So we also did some other experiment where we experimented with different lengths of the paraphrases being allowed to match. We found that if we only allow higher n-grams, like more than including trigram or higher, to do paraphrase matching, the correlation in fluency goes even higher. I think one of the reasons is that the word alignment program for unigram and bigrams are not really that good. So this could be a way of evaluating how the word alignment programs are doing. And we're waiting for data from the Berkeley Dan Klein's group where they actually did a bidirectional discriminative training to get a consensus for word alignments, but majorly for unigram and bigrams. So we want to see whether this will actually push up the correlations for ParaEval. So another important thing is that we need to distinguish humans and systems. So the humans are nicely clustered here in the left upper corner, and the systems are being clustered here. So if an automatic evaluation system cannot tell between humans and systems, then it's not very good. So here, all this correlation data and the graph is from calculating precisions. So as I said, we want to do a recall calculation as well. In blue, there's no recall because using multiple references, you allow the matching to happen in any of the references. That makes the calculation very difficult. So they do have a brevity penalty to compensate, so which is to penalize the systems that produce really short translations. So since we have a lot of paraphrases, and maybe it's possible to just use a single reference plus the paraphrases to actually get the effect of using multiple references. But we only correlate with adequacy assessment only because we want to see how much we got right. Because we're calculating the recall, we want to see how much in the reference translation we got it right, not reflecting the fluency from the peer translation. So here, blue does much better in recall with adequacy. And here's a recap of the overall correlation performance. So before taking the plunge to say that using single reference is enough, and we need to make sure that the single reference we're using is really good. What if you pick the bad one to use? So here I show the performance of the correlation from ParaEval using single reference at a time. As you can see, the correlation actually varies a lot depending which reference you're using. So here I did, the next table I did, it was using one of the reference and compare it with other three. So if all the translations are good and the paraphrases are good, then we are going to see like 100% overlap, hopefully, right? And also, well, in practice, probably you won't see 100% because people translate differently. They have their own style. So you will get probably 90%. So here it's clear that human 1 and 3 are, in a sense, better than 2 and 4. And also this correlate very well with the correlation figure they produce. So far I talked about the ParaEval for MT evaluation. This is also a good way to actually evaluate the quality of the paraphrases you extracted from your automated way. Because, as I said, if you compare human to human translation, if your paraphrases are good, you're going to see a lot of overlap between the human translations. Also, you can plug it in to evaluate MT systems and see the ranking. If your paraphrases are bad, then the correlation is going to be really low or even negative. So I have a group from Maryland who wants to evaluate their summaries using this framework. So next I'm going to talk about ParaEval for summarization evaluation. So like I said before, summarization is difficult because we're shrinking 50 documents into 100 or 200 words, and there's no sentence alignments in the evaluation, and we're looking at entire summaries. So there have been a lot of previous work So for manual annotations, we had a summary evaluation environment called C from Lin and Hovey, where summaries are broken into sentences. Then humans can assign partial credit or full credit for matching. And also there's a factoid and pyramid methods. They're very similar. They ask humans to sit down and break down the summaries into summary nuggets, and then compare, and using those lists of nuggets to compare, to grade the system-produced summaries and give a grade. So on the automated side, both of the previous work from Rouge and BE are still based on lexical identity. So in Rouge, summaries are broken into unigram, bigram, or other grams like skip diagrams. For BE, what we were trying to do was to break summaries into variable lengths but still meaningful. I think we tried using logical forms from this lab too. So what do humans do naturally in text understanding and comparison? We have the ability to actually recognize semantic equivalence between sentences and text. So what they do is basically paraphrasing, if we can state it like that. So this table is actually from the pyramid method, where a human was asked to create those nuggets from 10 different summaries, and here is the text segments the human picked to form the super nugget, where the super nugget carries the same information as the rest of the 10. So using our ParaEval, we would like to get this effect where the system can recognize all the 10 phrases are talking about the same thing. So for the ParaEval's comparison strategy for summarization evaluation is that we break it into 3 levels. At the top level, we do multi-word to multi-word paraphrase matching, and this is done using the paraphrase table and doing dynamic programming. And this matching is optimal because I'll talk about that later. But for the middle level, we want to do one word to n word and n word to one word or one to one word paraphrase matching. So there's no reason that those two can be together, but this matching takes a lot of time to do. That's why we broke this into a greedy match at the second level, just to save time. At the bottom level, we'll pick up everything that paraphrase couldn't match using lexical matching. This actually gives us a Rouge 1 guarantee, where if the paraphrase matching fails, then we can still have a Rouge 1 performance at least. So the overall score is a recall based. So here's an example where we want to compare those 2 summaries, even though I have aligned them nicely with sentence alignments. But here you can see that lexical matching will pick up the words in yellow, and paraphrase matching will pick up the phrases in blue. It's very clear that here, paraphrases are broken into different lengths, and this creates complication in matching. So the multi-word to multi-word paraphrase matching is an optimization problem. We want to favor the recall. So we want to give the system a better grade if they are matching more contents from the reference translation. But the complication is that we don't allow double counting on either side. If a phrase has been used in matching already, we cannot use it again. So that creates a problem, coupled with the different lengths, the tiling problem as well. So here is an example. So if we can break the whole matching processes, the whole problem, yeah.
Why is double counting a problem for recall?
Because on the reference side, if I already matched the phrase, I don't want to match it again.
But it's a recall metric, and the summary length is fixed. So.
So what if the summary has another phrase that's the same, and the reference actually has another phrase as well?
Well, your recall is still going to be just the one thing in the reference that you matched.
Mm-hmm. So.
And if the human summary actually repeats some material and you match it in both repeats, then maybe that's okay. Maybe there was a good reason to repeat it.
I don't think that's fair for the system, right? I don't think that's. Yeah, I mean, you could do that. So I'll recall. No, I don't think that's fair for the system. But also, so it's obvious in paraphrase matching, right? If this phrase has been matched, and this on the peer side, maybe you have 3 different phrases. You don't want this phrase to be used again to match for another paraphrase, right? I mean, what if this paraphrase actually gives another better match later in the reference side too? You know what I mean? Like in reference, you have 2 paraphrases, and you don't know, right? If you allow everything to be matched here, then the system has exhausted all of these phrases. What if another paraphrase happened later? Then you want to give that credit too.
Okay, I'm not sure. Maybe we could get into that later.
Okay. So here in the example, if we can break down the whole comparison process into n stages, each stage corresponds to a sentence from the reference side, and compare each reference sentence you compare with the whole peer summary. So for example, R2 can be matched with P1, and also R1 can be matched with P2. This creates a conflict because R2 contains R1 completely. So at this step, if we allow a greedy match to happen, we'll just take R2 with P1. But then when we move down to the next stage, where R3 can also be matched with P1, and R3 is longer than R2, we want to have. So what are we going to do here? We have to go back and create this correct this mistake. Also, we remember at the previous stage, R1 and our P2 can be matched too. So overall, we want to delete R2 and P1, the match there, and allow R1 and P2 to happen. So overall, this allows the peer to get more credit. So to evaluate the ParaEval's performance in summarization evaluation, we also did the same thing using the past stack data, where human assessments were also available. So we graded each summary produced by each system and assigned the overall score for each system and compared with the human scores. And we used the DAC 2003 data, where 18 systems were involved and 4 sets of references, and it was multi-document summarization on 30 document sets. So here's a correlation. So I only show root 1 here because our underlying counting strategy was unigram. So it's not fair to use root 2 where a weighted score may happen. So all the stuff, all the contents were matched with the same, but only the counting strategy was different. So ParaEval Para only was using only the paraphrase matching. That gives a 0.41 correlation. And ParaEval 2 was using the greedy match and the lexical match. So ParaEval 3 allows all 3 matching happen. So I didn't show the correlation, the confidence interval here, but it's significant, the improvement from root 1. So for a detailed comparison, when we compare human summaries with other human summaries, if we are using only root 1, the blue dots shows all the comparisons. So this also shows that humans have a difficult time to create summaries as well. If we all agree what should go into summaries, then we should have 100% overlap, ideally, right? But people disagree, so the maximum you can get a lot of times is like 60% or 70%. But Rouge, using lexical matching only, gives around 30 to 50%. But using ParaEval, we can go up 10 to 15%. More. So I have never talked about the qualities of the paraphrases we extracted. Are they really good or bad? But we can expect them to be really noisy, right? But we can see that they are still effective in the MT and summarization evaluations. So it's easy to see that in MT eval, all the sentences are aligned together, and there's not a lot of differences in verbalization. Well, a lot of words are picked up by lexical matching, then the rest of them are picked up by paraphrase matching. So I tried to do a manual evaluation there, but we saw that almost over 90% all the phrases matched are really paraphrases of each other. But it's more interesting to look at a human evaluation in the environment of summaries. So we had 128 pairs of paraphrases, and where the sentences where they came from were used as context information, and we had 3 judges. So the results are the average precision is around 68%, and the interhuman agreement was around 5.582. One of the so the annotation task was, okay, here you have 2 phrases, and here are the sentences where they came from. Tell me if they're paraphrases. So the answer is yes or no. But one of the human annotator gave me 10 different answers. It was like 20% this, probably, yeah, 80% no. So it was, yeah, so between the first 2 humans, the interhuman agreement was around 85, but the third human, actually the one who defected to Microsoft Asia, gave a really detailed annotation. So this brings down all the kappa values. So here's our 2 good examples on the paraphrases we matched and produced. So here, 10 years and a decade were matched together, and a guarantee and to ensure were matched together. So here, this example shows clearly that we want to go across the different syntactic categories to allow matchings to happen. So also humans voice that it's very difficult to measure semantic equivalence. In some situations, those 2 phrases, yeah, they carry the same information, but the sentences where they came from, the sentences carry different information, so it's hard for them to say, well, yeah, they are the same. But in other situations where the sentences are talking about the same thing, sort of, but the phrases are different. So those judgments were very hard to make. So to conclude my talk, I talked about using paraphrases to do MT and summarization evaluation. To do this, we get more content being compared, and the evaluation correlation turned out to be good. Some future directions, I would like to do more paraphrase induction for MT, where if I don't know this phrase, but I have seen it in some kind of environment before using context information, I want to induce that, okay, this phrase is the other paraphrase, the other phrase's paraphrase, and use that phrase's translation. Also, we want to do longer paraphrases, possibly to the Microsoft paraphrase level, but it's very difficult to grow from a small phrase to a long sentence. Also, we want to do more, measure more about word alignment errors. And also, if we improve the word alignment program, we can get probably better paraphrases as well. And another thing is we can directly use them in text generation to recognize more and precise redundancy to do more summarization or other tasks. So thank you.
Question.
Yeah.
Have you ever investigated the accuracy of paraphrasing, impact of accuracy of paraphrasing on the performance of evaluation?
I'm sorry.
You have different paraphrasing technologies, some are good, some are bad. Have you investigated the performance of paraphrasing, impact of performance of paraphrasing on the performance of evaluation?
Yeah, so the paraphrase we extracted is from MT, right? So I'm not involved with the word alignment program. So if that program really improves, maybe we can see better paraphrases and use them into the evaluation framework and see some improvement. Is that your question?
Yeah, I mean how sensitive the performance of paraphrasing to the eventual performance of the MT evaluation.
I think it's pretty sensitive. That's why I didn't include unigram and baragram paraphrases. So also we can do machine learning on which, using translation probabilities to filter out bad paraphrases too. So that's a whole different thing.
Do you have any careful results to show the sensitivity?
I have. Using unigram and baragram is much lower. We're seeing like around 10% lower in correlation. So that indicates those things are bad. So when we adjust what kind of paraphrase we allow, we see that the unigrams a lot of times we're matching off and off the. So I try to filter them out, but bad examples come in, and it really affects the matching process.
I guess a related question, which is, once you start introducing these lexical matches into the evaluation process, either for Rouge or for Blue-like matching, you're going to make the metric very domain dependent, aren't you? In a way that it isn't in its original form, where it's neutral as to what the vocabulary in this domain might be. It's just n-gram matching.
Okay, so you're saying like maybe the paraphrase could be domain dependent.
Well, if you're training on novel data, data from novels, and now you try to test on technical data, you're going to get a very different kind of behavior out of the metric than you would with just straight statistical n-gram matching. Right?
Yeah. So.
It might work well, and sometimes it might be horrible.
Yeah, that's why we have the lexical default, right? If the paraphrase fails completely, then we still have a lexical matching there. But hopefully, if the word alignments and extractions are good enough for whatever the domain you move to, then we can just do the same thing and see how it goes. So
I think a few question is that something like if you learn the paraphrasing from a specific domain,
okay.
then a machine translation system which trained on the same domain will get high score, right?
So we actually had this conversation at ISI with the MT group where we were thinking, are we really favoring the system? Yeah. But so what's wrong with favoring them? Because we know the phrase is better and we are allowing better phrases being matched. So maybe that's a good thing, right?
Well, if you're tracking the changes in the system over time, then it's probably
it's good
to across.
Yeah, it's good. It's okay to evaluate just one system, train it on the same domain. Let's say.
Well, if you're evaluating multiple
systems.
Well, if you're evaluating multiple systems, as long as you have a fixed set of paraphrases that was extracted, say, beforehand,
and everyone on the same domain.
On the same domain, or any domain for that matter, right?
Right.
Yeah. As long as you would use the same inventory of paraphrases, but it does make it like if you were to publish a number, right? Right now, I publish a little number, and you can sort of take a guess as to what that means, but that would become kind of impossible in this case because it would depend on how.
Training data.
How well the paraphrases matched your data, basically.
In that case, in that sense, I would like to see, for example, can you use some thesaurus like WordNet, since it's very general? Maybe I have a test.
I think there was work from Maryland where they use WordNet to do machine translation, but they do train it, so they have a set of features they track. So I haven't used WordNet in MT evaluation, but I have done it using in summarization evaluation. It could just be the summarization task is really hard, so the performance correlation was really bad because WordNet only really looking at like single word or at most 2 words, so it's really bad. We want to have longer phrases, so I can show you the data. I have it. It's really. So that's first we wanted to do that, and we saw the performance was so bad. So we were like, oh, we need to come up with our own paraphrases.
At the moment, you are only contemplating extracting paraphrases from translations, or do you have other working on?
Of course, I would like to do it in monolingual too. So instead of going through another language as an anchor point, if we have some kind of way of recognizing phrases in English alone, then extract them. That would be better. So I don't know, I think for the future I would like to apply like machine translation techniques into monolingual area and extract phrases that way to see whether it's good. I've done like some work in calculating similarities among sentences and try to extract. It's pretty hard to limit to like, oh, I know the sentences are similar, but I don't know which phrases are similar. So maybe we can use this kind of thing to basically grow out and see where it leads to and where it leads. Yeah.
So in your paraphrases, do they have any with them, or do you say these two are paraphrases or not, or is it a more graded thing?
So the scores we have are translation probabilities or translation confidence, right? So we could mix them together, but we're not sure how to translate the translation probabilities into semantic closeness. Even if I translate those two phrases 9 out of 10 times, doesn't mean they're more close than the other two phrases. They are not really translated that often. So there is this, so it's very hard to come up with a way of how to adjust this scoring.
Did you try some ways and they didn't work, or?
We just didn't want to, because we know the paraphrases are not perfect, right? We don't want to put in the score and see where it goes and really like optimizing on the correlation, which is kind of like, in my opinion, a bit hacking. What if we move to another?
But you do prefer longer matches, which is giving an implicit scoring.
So now we only allow, 5 words match to 4, we will get 5 points. So we don't put in the probability stuff. So if we can have a way of calculating in monolingual area where we can have this semantic closeness scores, then it will be much better. Or we can find out some kind of like translation probability mapped into the other probability. That would be better.
So you primarily have worked with English and Chinese multilingual data. Mm-hmm. Have you worked with any other pairs?
I haven't. So that could add more paraphrases or more noise. So that could be future work, but if you have data, you can send it to me. But that would just add more paraphrases. We can track whether there's a correlation. If you have maybe you have better French to English alignments, maybe that will produce better paraphrases. That could be possible.
And what percent of the sentences do you find paraphrase matches? So we see the differences, but what percent of sentences are actually affected?
For summary?
For both MT and for summarization.
For MT, it happens a lot. Every sentence have a lot of little paraphrases of each other. For summarization, it happens a lot too, but it could be just false too. So there's
because for the summarization, again, you're using the paraphrases extracted from E to C multilingual data. So I could imagine that you'd find much less. So in summarization it's less. That could also explain the correlation improvement is not that big, but in MT we see a lot.
And I also realized that the paraphrase learning technology can be used to extract phrase translations in machine translation. Right, so do you think that if we develop a machine translation system which uses that same technology to construct the translation tables, do you think that you will assign a unreasonable high score to such a machine translation system?
Probably, yeah.
Because I have always seen these problems. If you have some automatic way to generate a score, we can just use this method to create a system, right?
Oh, we wouldn't do that.
Well, there's also like...
That sounds like...
well, the paraphrases we extracted are from training data, not from testing data. So it depends on whether your system will do good on the testing data, right?
Okay.
Or we can just retrain it for every system and grade them.
Any other questions?
When you are learning paraphrases from the parallel data, what kind of lexical coverage do you get? What percentage of words or phrases, say NPs, do you actually find paraphrases for? We had a lot of examples around bombing, for example, and I can understand that.
Okay.
See this sort of data that we extract from monolingual data. But once you move out into something like tulip,
Okay.
example, which is Lucy's favourite example. She's very disappointed that I don't have any paraphrases for the word tulip. I don't get flower, for example.
Do you line them up and you will?
right.
So you're talking about the
So yeah, what sort of coverage, for practical purposes, what kind of coverage do you get of
So you're,
lexicon?
so you're talking about a density measurement, right? You want to see.
Right.
So that could be hard to measure because we can't just like say, well, take this collection and find it. It's really depend on what MT systems are training for. If MT systems are training for translating tulips, of course we can find tulips and flowers, I'm sure. I have an online demo, so maybe you can type it in and see. I'm not sure you'll find flower in it. But when I write papers, I actually type in the word I'm thinking of, and the paraphrases actually provide a lot of choices, and I do find it useful, even though it's not perfect, but still, it's pretty helpful than just using dictionary.com.
Okay, well, thank you very much.
Thanks.